So we're going to start talking about systems of equations, okay? Systems of equations. What we're talking about with systems of equations is that we're going to have two variables, two unknowns, okay? So we could, if I have a system of equations, they're going to show it something like this, and they're going to a lot of times put it back out in front. So that's what we mean by a system of equations. Which systems of equations, there's three ways in order to solve. We're going to start by solving by graphing, and then we'll learn what's called substitution and elimination. And this time we're going to have an additional packet to go along with it so that you're going to also do some worksheets and do some problems actually on paper this time. So just to let you know that, and have that packet with you. It will be handed out in class. If you don't have it, it is posted in Schoology, so you can print that off if you are absent. And make sure that you're getting the notes down somewhere so that you understand how to do it. So the first thing we're going to look at is you're going to actually graph this on the back in that last page of your packet that just has a whole bunch of grids. Just pick one of those grids and we're going to do it. And what we're going to do is we're going to first just graph this line right here using slope and y-intercept. So we're just going to start off by graphing this line. So what's our y-intercept? 5, right? So we're going to go up 1, 2, 3, 4, 5. Okay, now my slope is 2, so that's 2 over 1. So I'm going to go up 2 over 1, and I'm going to go down 2 and over 1. And I'm going to graph that line. Whoops, not a very good one. Let's see if we can do that differently. Let's try that line again. So we're going to graph this. Whoops. We're going to graph this line once again. And let's see if we can do it a little better. Okay, and this is where if you had a straight edge, and when I mean a straight edge, yes, a ruler works, your ID card works, the side of a paper works, so a lot of things you can use for a straight edge, but this is one time you're going to want it. Now, the reason I wanted us to start this way is because this line, okay, this line that we're talking about right here, is a solution set of everything for this equation. So yes, this is a point. This is a solution, and this is a solution, and this is a solution, but so is this, and this, and this, and this. Everything is a solution on this line to this equation right here. So when I talk about the solutions to this equation, everything on this line is a solution for this equation. So now what we're going to do, because I'm talking about systems, we're going to take the other equation, y equals 3x plus 4, and we're going to graph that on that same grid. So we started our y-intercept of 4. 1, 2, 3, 4. And now I'm going to go up 3, 1, 2, 3 over 1. And I'm going to go down 3 and over 1. Now this one turns out really nice because it shows up very quickly what our graph is going to look like. And wow, I have so many colors here. I'm just going to go back to that green. Okay, I'm going to draw this line in. Now this one makes it nice because it shows very quickly where they intersect. So where they intersect is right here. Now what that means is the green line is the solution to y equals 3x plus 4. The purple line is y equals 2x plus 5. Those are all solutions. But where they intersect right here, that is the solution to both. So when we talk about a solution to a system of equations, system of equations, the solution is the point of intersection of the lines. Okay, the solution of a system of equations is the point of intersection of the lines. Okay, so if And if it's a solution of equations, it can just be the point of intersection. Here we're going to have lines. In this unit we'll have lines. But you'll see that on the EOC and next semester, we can have systems of equations that are not just lines. But where they intersect, that is our solution. So today what we're going to do, or in this lesson, we're going to find out all the places where these lines intersect, and then we're going to find the solution is where they intersect. Good, let's do it. So I just want to be very clear, to solve a system of equations by graphing, okay, I'm going to first graph each line on the same coordinate plane. That's important. And 2, the solution is going to be where the lines intersect. Okay, so I just wanted to have it very clear. What are we doing in this lesson? We're going to graph them, find out where they intersect, then we're going to state our solution. Now our solution is going to be an ordered pair. Okay, all of our solutions will be an ordered pair. Let's do it. So the first one we're going to graph is actually in your book, if I remember right. And it is example number 1, where it says try it number 1. And this is on page 76. So if your grid is not like this, and if I remember right, it is not, you're going to probably want to draw in an axis. So about in the middle, draw in an axis on yours. Mine came with an axis. Draw in an axis. Okay, so we're going to draw in an axis. Now, do yours in black. I'm going to erase mine so then I can actually use red to draw lines. Okay, and if you happen to have 2 different colors, that's great, because then you can see each of the lines and have a straight edge out. Have a straight edge out. Okay, so here we go. I'm going to graph the first one. I'm going to start at y-intercept of -2. I'm going to go up 1 and over 2, down 1 and over 2. I'm going to take a straight edge, and I'm going to draw that line. Okay, there's my first one. Now I'm going to draw the second one. I'm going to start at -7. I'm going to go up 3 over 1. I would normally go down 3, but you can see I'm going to be off the grid. So I'm just going to keep going. 1, 2, 3 over 1. And I will tell you, that's one of the little things that I do a lot with systems. This would be my tip. If you're solving by graphing, then use slope. Okay, keep going with slope until they intersect. You find the intersection until you find, let's do it that way, until you find the intersection point. You don't have to do that, but because it's kind of, sometimes our straight edge moves, whatever, I can just keep going. And this one, it worked out very well. So now I draw my 2 lines. If you have a straight edge and you're not on a screen, if I put a straight onto this, it freaks out. So I'm not going to use a straight edge. Now, where do they intersect? They intersect right there. What is that point? That's the point 2, -1. That is my solution. Okay, now if I wanted to check it, I could actually plug it in. Oh, for the heck of it, let's just do it. So we're going to plug it into the equation. We're going to take y equals 1/2. We're going to plug in x there. And then we're going to do y equals 3 times. Okay, and in place of x and y, sorry, we need to erase that. In place of x and y, we're going to put our x and our y values. So in place of y, I put -1. In place of x, I put 2. Let's see if that actually works out. So I want the right side to be -1. So this 1/2 times 2 is 1. That's going to give me -1. Yay, that one works. Then this one I have 6 minus 7, which is -1. That one works. So yes, not only did we graph it, we also checked to see if it worked. We plugged it in. Yay. Okay, so this is my tip. I'm going to tell you my tip again. Graph it, but keep on going with slope until you find out where they intersect. Good. Let's go to the next one. Okay, so use the graph to solve the systems of equations. And I would love it, actually, if you would pause yours and, oh wait, let's do the first one. Look at the first one. We're going to start at 10. By starting at 10, I think we are already off the grid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that's the problem with that one. So let's see if I can move my grid a little. And if I were you, start your grid up a little higher. So don't do it right in the middle. Don't draw, you know how you're going to draw your axes in? Don't draw it right in the middle. Actually kind of move it down a little bit. Maybe start off the middle so you can get it 10 up. Or maybe start up here and count 10 down to 0 and make your axis, okay? I'm going to see if I can move mine. I forgot I can't move mine because mine is just a picture. So we're going to just do this the best we can. And again, I would recommend that you turn off, pause your screen, and try graphing it on your own. So here's 5, 6, 7, 8, 9. It's about right there. And normally you would go up to, but you can't go up any further. So I'm going to go down to, and then over 1 to the right. And I'm going to go down to 1 to the right, and down to 1 to the right. Okay? And that would give me my first line. And I did a few extra points just because I know my equation is a little off. Now on the second one, I'm going to start at 1. And now I have a negative, so this is a negative 1 over 4. I like to put the negative up top, so I'm going to go down 1 and 4 to the right. And now I'm going to go up 1 and 4 to the left. Oh, I bet you I just didn't draw my line well. Let's go back and check that. Go back to the red. Before I was going up 2 and over 1, but I had to go down 2 and to the left. Yes, look at my line would actually go right there. So that is our point of intersection. Okay, so keep on going with your slope until you actually get it to work. And so then you can kind of see where they intersect. Okay, so we found our intersection point. It's going to be right here. What is that point? That is the point negative 4, 2. So our solution is negative 4, 2. And if we wanted to check it, we could just plug it in. So this is how you solve by graphing. Okay, you graph both of the equations on the line. Wherever they intersect is your solution. Okay, good. Now this one we're going to graph on a grid in the back of your packet. So go to the back of your packet. We're going to graph back there now. And I should have used this one for my last one because it would have been better. Okay, so I'm going to graph that first one. My y-intercept is 2. And my slope is 3 over 1. So I'm going to go up 3 over 1. I'm going to go down 3 over 1. Okay, there's my first line. Second line, I have my y-intercept is negative 2, 1, 2, and I'm going to go up 3 over 1, and I'm going to go down 3 over 1. Okay, now look, where are they going to intersect, people? What do you notice about their lines? Those are parallel. Where do parallel lines intersect? They don't in Euclidean geometry. In the math we're in, they don't intersect. That's a whole nother story. I'll tell you some other time. Parallel lines don't intersect, so it's a no solution. Okay? They don't intersect. By definition, parallel lines don't intersect. So, and we know that by definition, or by what we learned, in order to find a solution of a system of equations, they have to intersect. So if I have parallel lines, they don't intersect. Now, you might have noticed before we even got started something about these equations. Look at their slopes. And we talked about this briefly. If my slopes are the same, I have parallel lines. And that's going to be really helpful to know. If I have the same slope, my lines are parallel. Okay? Good. Let's do another. So again, we're going to do one at the back on our grid paper. And we're going to start by graphing that first one. And we're going to start at our y-intercept of 5. 1, 2, 3, 4, 5. Now we're going to use our slope of 1 over 5. So I go up 1 and 5 to the right. And then down 1 and 5 to the left. Wait, 1, 2, 3, 4, 5. And then using a straight edge, connect those points. There. Okay, good. So that one's ready to go. Now the next one is not, because it is not in slope-intercept form. We want to get y all by itself, okay? Y all by itself. So we have to get rid of that 5. Therefore, I'm going to divide every single term by 5. So I get y is equal to, well, x over 5. Remember, we can always put a 1 there. So 1/5 x plus 5. Okay? Then we go and we graph it. We plot our y-intercept. Okay? Then we're going to go up 1 and over 5. We're going to go down 1 and over. Oh, hello. Did I not miss this? I'm so busy. Okay, down 1. It's looking like it's the same line, people. Because it is. Look at your back at your equations. Look at those. Those are the exact same lines. So now, where do they intersect? Everywhere. They intersect everywhere. So how do we write that? How do we show that everything is a solution? we write many solutions because there are infinitely many solutions. All of these will make this true. So there are infinitely many solutions. Okay? And we kind of probably figured that out. When I got here, I know some of you are going, hey, wait a second, we saw this before. But I wanted to show you, you still need to graph them both. Make sure you do that. Okay, so these are in your book. These are example 2, and it even says the title, Infinitely Many Solutions and No Solutions, or whatever it's called. What does it say? Infinitely graph systems of infinitely many or no solutions. Well, I don't want to give away the punchline, so I just had to do it on another piece of paper. And also, these are yucky to graph. Okay, so this one, no problem, y equals 1/2 x plus 7. But look at the second one. If I have to solve for y, I'm going to subtract 4x from both sides. So I get negative 8y is equal to negative 4x plus 12. Divide by a negative 8. Well, that first part is no problem. We're going to have a 1/2 x minus, and then I divide both of these by a 4. I get a 3/2. I don't really like to graph those. And also, I want to make sure you know how to graph on Desmos Calculator. So we're now going to take these two equations. We're going to go back to those originally two equations, and we're going to graph those on Desmos. Let's go. Let's put in those first two equations. So we're going to go y equals 1, and go 1 divided by 2, and then we move our cursor, x plus 7, and there's our first line. Let's move that down a little. We're probably going to need to see that. Okay, let's go with our second equation, and we have 4x plus, minus 8y is equal to 12. Okay, we can't even see that. So let's bring our screen in. And look at those. Those are parallel lines. So we have parallel lines now. So you could go back to your graph if you want to and draw in those as parallel lines, or just say, hey, these turn out to be parallel lines. Now, let's go back to my notes for just a second. And we could have probably figured out from right here, hey, wait a second, these are going to be parallel lines because look at my slope and look at my slope. So pay attention to that. So I just wanted us to get the chance to graph using Desmos. Remember, Desmos will be something that you will have accessible while you're taking the EOC test. So I want to make sure you're comfortable with it. And this is a way you could graph solutions. Okay, we're going to use it again in this lesson too. Okay, so same thing here. I want you to go out to Desmos.com. Hopefully you still have that open. That's Desmos.com. And graph these. Go. Now when you graph these two lines, notice if you look at my graphing, you can see that one of them is red. The second one is in red, but the first one's in blue. You just can't see the blue because they're the exact same line. Okay? And they do this on purpose. They make it so it's not in the same form, so you can't see that they're the exact same line, but they're the exact same line. So this one has many solutions because they share all their points. Okay, I wanted to look at this habits of mind because I wanted to point out again what's going on here. Other than graphing, how else could you tell that an equation has infinitely many solutions? If it has infinitely many solutions, it's going to be the same equation. So what you can do is get your equations in the same form. Like get them both in slope-intercept or get them both in standard form and then see if they are. Okay, I would of course recommend slope-intercept form because then they're ready to graph. I also want you to add to that how do I know if I'm going to have no solutions? If I have no solutions, okay, that means that I have parallel lines. And if I have parallel lines, the way I discover that is the slope is the same. So if the slope is the same, I have parallel lines, therefore I'm going to have no solutions. Good. Get that in your notes. I think that'd be helpful to have that. Infinitely many have the same equation. Parallel lines have the same slope, so therefore it's a no solution. So the next one we're going to look at is a word problem. Now, of course, this word problem is not in your book. It is just right here, so you're going to watch it, and then we'll go do the one in your book. And you're probably thinking, oh no, yuck, a word problem. Yuck, I don't want to do these. But guess what? This is the best time to do word problems because when you have a system of equations, you get to have two variables. If I have two variables, it's much easier to set up my equations. You're going to see that very quickly with these, okay? So let's read it first. Monisha and Holly have 14 more days to finish reading the same novel for class. Monisha plans to read 9 pages per day. That's going to come in handy. While Holly plans to read 20 pages per day. Why? Why are we doing that? Well, let's look. Monisha's already at 220. No, she's at page 96. And Holly's at page 60, so she has to do some catching up. Okay, so the first thing we're going to do is we're going to write equations for this. Well, what are the two things we're talking about? We're talking about that there are X number of pages yet to read. Number of pages yet to read. And your Y is going to be total pages read. Now they're both hoping to get to 220, but we can't guarantee that. That's not going to be what our equations are. So let's look at our equations. So Monisha has Y is equal to, well, she's going to read 9 pages per day, and she's already at 96. Okay, whereas Holly, let's do that in a different color. Holly has how many pages? She's going to read 20 pages per day because she's behind, but she's only starting at page 6. So it says, assuming Holly and Monisha both maintain the reading plan, when will Holly catch up with Monisha? So what this is saying, number of pages yet to read, and this is going to be the number of days. Number of days also. Okay, so where they intersect is when they're going to have the same number of pages as to what, same number of pages that they have read. Okay, so look at those two equations. Who wants to graph the y-intercept of 96? Nobody. So what are we going to use, people? We're going to go out and use Desmos. Let's graph those. Go. So my equations are y equals 9x plus 96. Okay, you can see that's not even on our chart. Okay, now we're going to go with y equals 20x plus 6. Okay, not even visible. So here we go. Let's move our chart down. Move it down, move it down. When do they come up with the same number of pages? Now, here's the other thing I want to show you, is that right now, we don't know what that point is exactly, and we're going to have to spread it out a little so we can see where they actually intersect. Okay, and it's a pretty big number, and you're going, well, I can't even read this. Oh, and look at the decimal places we're going over here. Okay, over to that left. So now we're going to find out where does it intersect. Right about there. And see, when I touch it, it gives me an ordered pair. When I touch it, it gives me an ordered pair. Now, let's look at that ordered pair. Can I read, whoops, went away on me. Can I read 169.64 pages? Nope. So what that's saying is that in 8 days, okay, after they've been reading for 8 days, because that's the number of pages I would take 8 times either 20 or 9. That's when they intersect, is at 8 days. So at 8 days they intersect, and keep that order pair. I'm going to write it back down in our notes so we can talk about that. Let's look at it. So we have that it's 8.8182, and we have 169.64 pages. So what this is saying is that in 8 days, because it's talking about 9 pages per day, so 8 times 9 would be, whatever. Okay, so we're going to say that in 8 days, this is days, and this is going to be total pages that they've read by that time. Okay, so in about 8 days, they've both read approximately 169.64. And with this, we're not going to get exact right now. We will learn how to be exact on solutions when we get into the next lesson, substitution, and then also elimination. So we would just approximate right now, also because we can't have 169.64. So we would say in 8 days, they would be about the same place. When will they catch up? In about 8 days, who will finish the reading novel the first? Okay, so we still would have to keep going. So that's like, for this first question, it's going to be in 8 days. They're both at 170 pages. And we would plug that, find out exactly. Now, who will finish reading the novel first? Well, what we have to do here is that notice our pages are 120. So what we would do is we would take each equation and set it equal. So 220 is equal, I'm going to do Holly's right here, 20x plus 6. We're going to find out how many days for Holly. And then for Monisha, we would take 220 is equal to 9x plus 96. So if I wanted to find the total number of pages, that's what I would go about doing. Okay, so let's solve those two equations. Go. So when you solve those equations, x is equal to 10.7 for Holly, so 10.7 for Holly, and for Monisha, it's 13.7777. Okay, so who's going to finish first? Well, it's going to only take 10.7 days, so about 11 days. And for Monisha, it's going to take 14 days. Okay, so Monisha will get it done. Holly will just get faster because, see, they have 14 more days. So Monisha is paced it out so she doesn't have to work. She doesn't have to do as many pages in every night. Okay, so this is an approximation. These are approximations. When we get into the next unit, we won't. The other thing, though, I wanted to point out is when you're graphing, and we're going to do those again in just a bit. So now what they're saying is let's change it a little. So now they're going to change it that Monisha is going to be y is equal to 10x plus 96. Holly did not change, so the only thing that changed is she's going to read one more page a day. And then they're going to find out how will that length of change time for her to catch up. Okay, you could graph them again, find that out. And let's do that really quick. So luckily I still have my equations out there, so I just went out and I changed it to a 10. And I'm going to find out where that changes it. Let's see. So we have to move it all the way up here to find out where it intersects. And it's going to intersect and it's going to keep on going. And it looks like about right there. Okay, we're going to say that's their intersection. So in 9 days, they would meet up and it would be at 186 pages. So a few more pages, a little bit longer, but that's where they would meet up. Okay, so we just could go into Desmos and change that. The second part would be, hey, when does she get done? Length of time it'll take for Holly to catch up. Oh, actually, we're done. It's going to take 9 days. Okay, good. So again, when it says an exact solution, we're going to try to find out what solution do you obtain for the system of equations by graphing. What is the exact solution? So we're going to go out and graph this and find out what the approximate is, and then we're going to have to play with it to find exact solutions. Let's go to Desmos again. So when you graph it out on Desmos, this is what it looks like. When you put that dot right there, okay, and in Desmos, when you do that, it will tell you a solution. Okay, that is our solution. So then what we do is we have to play with it to find an exact solution. We would have to take numbers right around here. So we might take 1.6 and 4.1, plug it in, see if it works. Okay, we're not going to spend a lot of time on this because after the next 2 lessons, we're not going to be doing it. But the reason I want you to see it is because if you're testing sometime, this might be helpful to be able to go out to Desmos and find out some solutions by plugging it in. So I'm going to take that first equation, y is equal to 5 times, and I'm going to, I'm going to start with 1.6. And oops, I have to put that y is actually, I have to change that, and y is 4.1. And we're just going to take our calculator and figure that out. That is not a negative. That is just 5. Okay? And then minus 4. And then we're also going to do the other equation. Well, let's just see, and then let's get the other equation. 4.1 is equal to negative 6 times the x value plus 14. Pause that, find out those values go. So I realize what they're asking for an exact solution. We already have done that. Oh, look, I'm going to trace it with a line. We already have the exact. But if we plug it in, you can see this one comes pretty close, 4.1 and 4. This one's not as good. Okay, oh, and that would be in a positive, sorry, that's a positive 4.4. So that just shows you can take a point, plug it in, find the solution. We've kind of done that. We're going to use a graphing calculator if it's not going to be an exact solution for now. Once we learn substitution and elimination in the next 2 lessons, we're going to get the answers that way. We won't solve by graphing. So this just kind of brings it all together, and it just kind of points out you're going to have one solution. If you have one solution, they're going to intersect. Okay, so if you have one solution, that means it's going to intersect. If I have many solutions, if they are the same line, then I'm going to have many solutions. And if they are parallel, and which means they have the same slope, then they're going to have no solution because they don't intersect any place. Okay, you've probably already written that in your notes. If not, this might be a good time to write down some of that information in your book someplace where we haven't used other space. So just find a place for that. Let's go into the essential questions that I do want to talk about this. How can you use a graph to illustrate the solution to a system of linear equations? Well, if I graph them both, graph equations, and wherever they intersect, that is your solution. That is the solution. So it's really handy when I graph it. Number 2, how does the graph of a system of equations with one solution differ from the with many or no solutions? Well, with one solution, they're going to intersect in one point. Since they intersect in one solution in one point, then that means that my solution is an ordered pair. It is a point. Okay, many solutions, okay, it's the same line. They intersect everywhere. And no solutions don't intersect at all because they're parallel lines. And we just kind of went over that with that last chart. Question 3, why is a point of intersection for a system of equations considered its solution? This is what we were talking about at the beginning. Because each line, a line, is a set of solutions. Okay? Solutions. Notice that S right there, solutions. So, if two lines intersect, it is a solution of both of them because of both lines, of both equations. Because each individual line is the solution for one line, and the other line is a solution for the other equation. But when they intersect, that's where we find the solution for both of them. Error analysis. Riesz states that the system of equations has no solution because the slopes are the same. Describe Riesz's error. Her error is that it's not going to be no solutions. It's going to be, wait, hold on. The problem or the error is, yes, it's no solutions if the slopes are the same and we have a different y-intercept. If they have the same y-intercept, so look at this equation. If I solve this one, if I rewrite this equation, I have to have them in the same format. So both in slope-intercept, both in standard form, both in whatever form. Because this equation is y equals negative 3x minus 1. So the mistake is that she didn't take into account that the y-intercept was also the same. If the y-intercept is the same, they have the exact same line. So it's many solutions. Now we get to graph some more. And so we're just going to graph these two lines. Go! And you might be thinking, but there are no grids in my book. But you can go to the back of your packet and there are grids, and that's where I got this grid. Or maybe they are in yours, and if they're in yours you just have to draw the axes in. Yeah, they're in there, just draw the axes in. Okay, so there's one line, and then I'm going to draw the other line. My y-intercept is 0, so I'm going to go down 1 and 2 to the right. I'm going to go up 1 and 2 to the left. Oh, hey, it looks like this is their intersection point. So let's go back to that other line and keep going. So I went up 2 over 1, down 2 over 1. So I'm going to go down 2 and over 1 again. Yep, that's their intersection point. And so that's the reason I like to keep doing slope until I find where they intersect. So my solution is negative 2, 1. Good. Now we get to graph again. So we're going to graph again, but look at that second equation. We need to get that in slope-intercept form. So I'm going to subtract 2x from both sides. I get 3y is equal to negative 2x plus 6. I'm going to divide through by 3. So I get y is equal to negative 2/3 x plus 2. Oh, baby, look, look, look. They're the same line. That's one of the advantages. If you get them in the same form, you're going to see they're the exact same line. So I only have to graph it once. This is going to be a many solutions. I can tell you that already. Okay? But if I were to graph these lines, notice they're going to be the same. I'm going to go down 2 over 3, up 2 over 3. There's my line. Even if I do it in a different color, it's still going to be the same line. Okay, so my hint here, get your equations in the same form before you start graphing. Well, that is it. Now you're going to go out and do practice 4.1 that is posted in Schoology in your folders. And if your teacher also has a worksheet, you're going to be doing that for homework. So thank you very much and have a good day. If you have questions, you know where to find us.